Welcome back to the engine history. Rewind to 1860. Engineer Etienne Lenoir put a cast iron block on the bench running on coal gas and air and locked it in the foundation for every compression and combustion power unit we have today. Today, we are not here to stand outside and watch a showpiece run for looks. We are going headfirst into the engine bay. We will breathe in air thick with the reek of burnt lubricating oil. We will measure the shock waves pounding out of a 17-ton Western engine. And we will open our ears to the sharp, hard-edged exhaust that tears at your eardrums from a Detroit diesel lineup. This is a real tear-down grade look at furnace heat, solid steel, and the most brutal kind of mechanical machining skill. From Lenoir's miserable 4% efficiency to a Gardner 6L3 pushing close to 40% in 1932, every tolerance milestone was paid for in sweat and steel grit by the people who cast and built engines. Take a hard look at machines like Slavia or the Perkins P6. They are not scraps waiting to be dragged into the mud. They are steel-hard logbooks of how tough an era of one-piece iron and steel really was. If you want to see the raw strength of mechanical drivetrains and help the team preserve real teardown load test data, hit subscribe to the Engine History. Your subscription and support are the pressure that keeps the team fueled to hunt down these legacy cast iron blocks and haul them back to the shop for load testing. Look closely at the Ewalker machining line from Switzerland, cast back in the 1870s. By building a purely mechanical camshaft control system, craftsmen back then cut and milled countless tiny fastener seats with perfectly meshing tolerances, without touching a single line of computer code. Now flip to the violent opposite end of the spectrum, a stationary Western engine rated at 200 horsepower. To make this giant bite into RPM, the crew had to work barehanded, palms packed with grease, grinding and fitting for months, feeding lubrication into every bearing shell, one journal at a time. The heat radiation blasting out, mixed with the smell of rusty steel filings, hits you the moment the engine locks into its working speed. It exposes the savage fatigue strength of the materials for real. Diesel compression ignition is the final boss of stubborn toughness. Look at a Detroit Diesel 453T being forced through a cold start under load. In freezing temperatures, the 9B90 high-pressure pump has to hammer out brutally high pressure with watchmaker-level machining tolerances, so the fuel charge will self-ignite on the very first compression stroke. Or look over at Slavia engines cast in Czechoslovakia. From the 8-horsepower units you spin up with a hand crank to the Heavy 2 ST120. These machines ditch glossy plastic covers. They only care about a rigid frame that can keep driving pumps and stone crushers on the harshest job sites. Every thick plume of black soot blasting out of a vertical stack is load data. It is the measurement of work being wrung dry. The marine side brings in the Regan Vapor engine, a unit that pushes past limits by forcing raw gasoline to vaporize before the high-voltage spark hits. Back on land, look at the John Deere Model D tractor, a configuration that beat up American farmland for 30 straight years with a 2-cylinder engine that hits its own sharp, hard exhaust rhythm. Whether it is biting into ocean swell or rolling a wheel down into soil, these machines lock onto one shared spec. Strip it down, simplify it hard, kill failure points before they happen. Oil film smeared thick across the block and gouges carved deep into cast iron walls expose decades of load and throttle data like scars you cannot fake. If V16 engines are heavyweight muscle, then small units like the Lister D or McCormick Deering are a precision tolerance problem. With modest output, they carry extremely sensitive centrifugal governors to hold a hard firing rhythm even when load changes suddenly. Instead of belching thick black smoke, these engines give off a thin mist from open cooling hoppers, a sign the combustion temperature has reached a stable operating range. Most of all, the mechanical break and make ignition on the Chorboy is a blueprint that defined the pre-grid era. That crisp tick-tick sound, paired with hit and miss intermittent firing, does not just stretch fuel, it builds a brutally smart technical solution. No machine is ever truly small when it carries a full revolution in the way cast steel thinking was built. When the fuel shutoff is locked and the engine note fades down, heat still pours off the block and seals the yard air with that heavy burn. One-piece cast iron blocks like Slavia, Detroit Diesel, and Gardner drive one eternal metallurgy lesson straight into your face. They do not need fault boards. They need an oil film and furnace fire, and they will grind time into dust. Thanks for sticking with the engine history through burnt smoke and hot grease while we held tolerances and read these machines. From a builder and fitter's viewpoint, what impressed you more? Detroit's cold start load forcing spec? Or the Swiss machining tolerance precision? Drop your take in the comments so the crew can dig in. See you in the next round of welding, fitting, and load testing.